In today's video, we're going to be talking about volume and volume of specific three-dimensional figures. So what volume measures is how much is filled inside of a three-dimensional object. So in this first example, I have a rectangular prism, so pretty much a box. Okay, the volume would be if you filled this box up with water or sand, or how much of that water or sand is going to fill up the entire object. Okay, so a little bit different concept than maybe you've learned in the past when it comes to area. Area usually refers to two-dimensional figures. Volume correlates to three-dimensional figures because you're seeing how much of an object is filled. All right, so there's important volume formulas. Okay, in the rectangular prism, the volume formula is length times width times height. And if you're given a word problem, it says, what is the volume in cubic inches of a rectangular prism with a height of 9, width of 4, and length of 5 inches? So basically, you're just going to use your volume formula and plug in your numbers. So the height would be 9, right? The width would be 4, and the length would be 5. So it would be 5 times 4 times 9. And what's helpful in these problems is a calculator. 5 times 4 times 9. And that is 180. So 180 inches cubed. Okay. So that is how much that's how much the volume is for this specific rectangular prism. Okay, let's look at another figure. A cylinder, or like a can. All right, so we have different parts of the cylinder. We have the height of the cylinder and the radius. The radius is from the center of the circle to the edge of the circle. That's the distance of the radius. And our formula is pi r squared h. So a cylinder has a base radius of 10 meters and a height of 10 meters. I'm going to change this so it's a little bit different so that you can see 15 meters. Let's change that up. What is the volume in cubic meters to the nearest 10th spot? Because you are going to get a decimal when you're using pi. Okay. So I want to write, not move it. So my volume, so I'm plugging in the radius is 10. So that's going to go in for my R. 15 is going to go in for my H. So we have pi times 10 squared times, what was it, H, or is 15. Okay. And again, use your calculator. It's your friend. Clear all. So we have pi parentheses 10 squared. Definitely helps to put in the parentheses just like how I did it, times 15. And you get 4712.38. So I'm rounding to the nearest tenths. So 3, I look after the 3, it's an 8. That bumps this up to a 4. So it's 4712.4. 4712.4. What we got? Meters cubed. All right. So there is my volume, rounded to the nearest tenth. Sometimes they might ask for it in terms of pi. So if they ask for it just in terms of pi, that means you're going to leave the pi here. All you have to do is figure out what these two numbers are, 10 squared and 15. So in your calculator, I'm just going to figure out what 10 squared by 15 is 1,500. So this is also can be written as 1,500 pi. As maybe you'll get on later on into either algebra or geometry, they might ask you in terms of pi. Okay. So this is in terms of pi. This is with the pi rounded to the nearest tenth. And let's look at one more figure. We got the cone. Okay. So the cone, we have the radius, the height, and since it's not like a cylinder, it's kind of, if I had a cylinder, right, it would look like this. And it's actually cut into, when you make a cone, this top portion is divided into three parts. So that's why there's a 1/3 at the beginning, because you're pretty much cutting the cone and into three parts by doing this. So that's kind of just the visual representation of the volume of the cone. Because this part is right here, right? That's the cylinder formula. You just saw that over here. That's the same exact thing over here, but you're just multiplying it by 1/3. All right. So the volume of a right circular cone that has a height of 8.8 and a base with a diameter, careful with the word diameter, 18.6, because we need to find the radius. Round your answer to the nearest tenth. So whenever they give us the diameter, all right, we have to cut it in half to figure out the radius. So the radius, just always remember, is going to be half the diameter. Okay. All right. So we have our formula, right? So let's find the radius of this figure. So the radius, the diameter is 18.6. So 18.6 divided by 2 is 9.3. So that means this has a radius of 9.3. So that's going to go in for my r squared. That didn't look like a good arrow. There we go. R squared, the 8.8 is going to go in for the h. And so my volume formula is going to be 1/3 pi r squared, right? So 9.3 squared. And the h, where's the h? It's 8.8. Calculator, 1/3 pi. 1/3 pi. Parentheses. What was it? 9.3 squared and 9. I want it inside the parentheses. 9.3 squared. Close the parentheses and then open up another parentheses and put in 8.8. Bam. Boom. 797.03. So since I'm rounding that to the nearest tenth, it's 797.0. Point 0. What do we have? Centimeters cubed. All right, that's rounded to the nearest tenth. If I wanted it in terms of pi, let's take the pi out. Would that be a nice number? Not really nice. So I'm just going to leave it in terms of pi. And then, so there is my answer to the volume of a cone. So really important that you first of all know radius is half the diameter. And then once you find the radius, then you can plug it into the formula. Same thing it goes if you did this problem over here. If they gave you a radius, or if they gave you a diameter, If this said diameter of 10, you would have to cut it in half and make this 5 instead of 10. All right, so be careful when you're doing that. So that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.